Okay, welcome. Today we're doing radians and measuring circles because why not? Okay, so number one, let's load up the screen. So here are a few videos by Bison Math. They explain a bunch of concepts really good, so we're just gonna watch through them, do some of my textbook problems, and just learn the concept.
And then, so we're going to be looking at radians. And radians you may have heard of. There are people in the class, if you do further maths, you probably know about some of this already. So you can see this as a bit of a recap. And radians are basically a different way of measuring angles. And they are, in many ways, a more superior way of measuring angles. And we're going to find out a lot more about that. So the first thing we're going to be starting off is learning what actually are radians.
Harish, what do you want? Why are you here? Did you lose the ball?
It's not that. I don't know. Look, Guru's lying us, okay? So then he won't give the racket to Pranav. Okay? So then we just left him.
Okay, nice.
And now he had the ball, and then he's like, I will give you anything if you just give the ball.
Okay.
And now he said, we'll give you chocolate, and then he said, it's in the fridge, okay? He's like, Nane, poi edutha, and then he went on.
Let's close the door, Harish. No. No, the Rana something about he broke it.
Oh, not the Rana.
Oh yeah. By the destruction. Let's continue.
Bit of a recap. And radians are basically a different way of measuring angles. And they are, in many ways, a more superior way of measuring angles. And we're going to find out a lot more about that. So the first thing we're going to be starting off is learning what actually are radians. Why do we use them? How are they related to degrees? And then as we go through this chapter, we're going to be looking at things to do with geometry again. We're going to be looking at stuff that you may have been familiar with either from GCSE or from things that we did in year 12 to do with like the sine rule and the cosine rule, but we're just adding some things in using radians. We're also going to be looking at solving trig equations in radians, and that's going to be a great opportunity for us to recap some of that stuff from chapter 9 that you've all watched my videos of, even though I wasn't teaching you. And then the last thing we do is a very, very small thing called small angle approximations, which is something that is new to the A-level from the last few years, and so it's not really come up very much. But I will tell you more, obviously, about that when we get to it. Okay, so we're going to talk about radians to begin with. Like, what actually are radians? Well, I've already said that it's something to do with measuring angles. So I've said here, so far we've used degrees to measure angles, with 1 degree as a 360th of a rotation around a full circle. Any ideas of why we've done a degree as 1/360th? It feels like a really random number to have picked. Why do you think when people were trying to do degrees, they decided to do 360 as a full circle? Any ideas about 360? Well, 60 is a very special number because it's divisible by 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, which means that a circle can be split up into lots. It can be shared out among those pieces really nicely. So if I wanted to take a full circle and split it into 12 pieces, instantly each of those pieces is 30 degrees. And so that's very convenient if you're doing anything to do with measurements, or if you were trying to. So 360 was used as the original number for the number of degrees in a circle. 90, 8 degrees, loads of ways that it can be split up. So that's why 360 was used. But it's funny because you have always thought, oh, well, 360 degrees is used. You know, someone one day picked that. It's not true. It's just someone said there are 360 degrees in a circle. So you need to start thinking radians is just a different way of measuring things. 1 radian, however, and this is the definition of a radian, is the movement of 1 radius's worth around the circumference of the circle. In other words, if the arc of a circle is equal to its radius, then the angle subtended at the center is 1 radian. So I'm just going to pause there because that's.
So what I understand from this is the length, so the radius. Oh no, one radian is equal to the arc length equal to the radius. So if this is the radius, the arc length of the outer edge should be equal to the length of radius. Oh, so then if it's two radian, the arc length would be twice the length of the ray. Oh, wow.
Sounds really confusing, and this diagram is going to help us. So it said, in other words, if the arc of the circle, which is here, is equal to its radius, so this curved line here is the same length as this line that we've got here. If that is true, then the angle that is subtended, which is a posh way of just saying the angle that's at the middle, the angle.
What? No, Let's continue.
At the middle is 1 radian. So it's very different to how we've measured degrees before. It's just a different definition of it. And you're going to have to trust me about why this definition is so important. Because it relates, it makes so many other things work.
Wait. After this we are there. But then if the door Ma, when will my other books come? Not that door. It's close enough. Why? Let's continue.
Properly. Okay, just have to trust me with it for a while. So I've said outside geometry, mathematicians nearly always use radians. You'll have to trust me that this will make more sense why later in this chapter, and it's to do with calculus. You know, when I say calculus, what do I mean? What do I mean calculus? Differentiation and integration. Differentiation and integration together is calculus. And calculus only works if we use radians, and you'll see why that is true later on, okay? So this is 1 radian is when this outside section, that distance, is exactly the same as the distance of 1 radius. So I'm going to show is exactly the same as the distance of 1 radius. So I'm going to show a bit of a demonstration here that will help us visualize what is happening. Let's see if I can make this full screen. Okay, I'm actually going to make the radius 1 just for the sake of this demo. Whoops, not 0.99. Oh, for God's sake. That would be the rest of the lesson, me trying to get it to 1. Okay, and I'm going to zoom in a bit.
Hey developers, join us for the biggest AI competition with over $10,000 in cash prizes. Yep, that's right.
Okay, so at the moment, this angle theta, we don't know how many radians it is. But when I move this around to here, that is exactly 1 radian, because this blue line is 1 length, okay? Now, as I keep moving it around, I have another radian, because it's now 2 lengths of the radius around the outside. And then over here, I would get to 3 radians. And then over here, what do you think the number of radians is? It does actually say, but how many radians is over here?
3.14.
It's pi. It's not quite pi because of the way I'm dragging it around. It's pi radians. I'm going to try and work out why it's pi radians in just a second. So as I keep going around, I've got 4 radians, 5 radians, 6 radians, and as I go all the way back to the beginning.
Because the circumference of a circle, how do you calculate? 2 pi r. What is 2 pi? 6.28. So if you calculate, if the radius is 1, then you have 6.28 radians.
4 radians, 5 radians, 6 radians, and as I go...
See, you can see here, 1, 2, 3, 4, 5, 6, and a little bit. 6.28. Makes sense.
We want to show you a surprise.
What?
Tada!
How? Is this the new one?
No, it's like that. Like we just found it.
Ball, what?
Batman.
Oh, you're the doll, keep on smacking.
I wish I could. That's
So hard.
Ah!
I'm gonna throw you.
It's not the new one.
I know, but like. So
What did we
Who
do?
cut this?
We didn't cut it.
Perfectly cut.
It was black.
Looks like a ball. You lost that one.
Huh? Not me, good enough. We're doing everything so he gets it. He only took it and hid it somewhere. Or he or something. Why is there a cup on top of the cupboard?
There's a reason. Ants.
Then just go down and give it in the kitchen! What do you want? What do you want? What do you want?
You take your half.
What do you want?
Take your rubbish.
That was rubbish with that. Oh, you can't do it.
Close it slowly, please.
Just close the door.
Let me undistracted.
All the way back to the beginning, it's 6.28, which is 2 pi, okay? So we're going to try and work out why that is true. Let's go back to this page here. So let's think about it, what we just said with a semicircle, okay? If this distance here is 1, what is this distance around here?
2.14.
What is the distance? If this is a semicircle, the radius is 1. It's just pi r, isn't it? Because the full circumference is 2 pi r.
So if you divide it by 2, this can't be 2 pi r divided by 2 because you're taking half the circumference is pi r. So obviously, it's 3.14.
Just pi.
And then if it's pi r and your radius is 1. I need. Yeah.
R, and pi r is pi multiplied by r, which is in this case just 1. So that is why, because the length of this arc is pi, that means that the angle in the middle is pi radians. Just like here, the length of this is 1 and the length of this is 1. The definition says that radians is 1. And so if you have a full circle, So we're going to say
It's
that's the radius
2
1.
pi
We want to know what
radians.
is the arc all the way around the outside. Well, we know it is 2 pi multiplied by r, which is 2 pi multiplied by 1, or 2 pi. That must mean that the angle inside here is 2.
Let me see if it's 2.
Pi radians. Okay? So that's the main thing I want you to commit to memory is this, okay? Half of a turn is pi. That's all you need to, that's what you need to start off by knowing. Half of a turn of a circle is pi radians. And I've got this nice diagram here that is going to help us see some of these connections, okay? So I'm going to ask you in just a second to fill in the equivalent angles in degrees around the circle. Now, I don't know if you remember this from any of the videos you've watched of mine on trigonometry, but which direction do we measure angles on this diagram? Anti-clockwise. Yeah, it does say it up here, but if you didn't read that, I'm hoping you remember that they measure anti-clockwise, and you start from this section that we have over here. That's why on that demo we just saw, they were starting from the positive x-axis. And because pi is equivalent to 180 degrees, you should be able to fill in these other degrees purely with your knowledge of fractions, okay? So obviously up here, we know that this angle from here to this line is 90 degrees, but also I've got that it's half of a turn, and half of a turn is 90 degrees. Could anyone just tell me any of these other ones? Just tell me what they think it is in degrees and why they think it is in degrees, and then I'll let you have a go at doing them yourself. Which one is 45 degrees? Pi over 4, yes. So this is because it is a quarter of a turn.
Yes. Because half of the circumference of the circle is equal to 1. No. Sorry. The angles of half a circle is equal to 180, and you also know that the amount of radians in half of a circle is pi. So then, if this is 90 degrees, which is half of 180, and you also know that pi is also equal to half the angles. No, pi is the amount of radiance is pi. No, yeah. So pi is the amount of radiance in half of a circle. So if it's half of that, which is a quarter of a circle, that would be pi by 2. Oh my god.
Of a half turn, a quarter of this 180 degrees turn. And a quarter of 180 is 45. Could you just tell me one more? Harmon, one more?
270 is 3 over 2 pi.
Yeah, and we'd actually probably call this 3 pi over 2, but you're right, it's the same thing as 3 over 2 pi.
Why is let's see. Oh, it's just 1 by 5 pi because this is 1 pi. You have another half, so it's 1 by 5 pi. Okay.
But just getting in the habit of how we tend to say things, but perfectly correct what you said. Maybe just one more from Ahmed. Yep. Yeah, good. 3 over 4 pi is 135. What were you doing in your head there? Yeah, what were you doing? How did you come up with 135? Yeah. So you're thinking of what is 3/4 of 180. So I'm just going to give you a bit of time to fill in this circle. If you have finished filling in the circle, I want you to just try and remember as much of it as you can, because we're going to do a bit of a game to try and figure out where these things land in a second. So I'll give you a bit of time to have a go at that.
Okay, let's see. Can you do this? Is there not any way for me to edit this? Oh, there's still a whiteboard. It's fine. So what I understand from this is basically you see it's 7 by 6, right? 180 divided into 7 by 6 will give you the amount of uh, the the amount of no the measure of angles in degrees. Because like that's essentially what you do. Because like the 1 pi is equal to 180. So if you put 7 by 6 into pi, you're putting 76 into 180, which means that'll give you the amount of degrees. So yeah, you just do this essentially.
Imagine this on your resume, a certified expert in ChatGPT.
Now you gotta be jobless to actually sign up for a course like this, bro. Quill? No, that's crazy. You need a certificate to show that you can use Pro. My brother could use that. Just go onto YouTube. Every tutorial's on YouTube. I'm learning from YouTube. You don't need any certificate. These ads are just terrible.
And AI tools. Sounds impressive, right?
Sounds so. I'm gonna make a video of me just learning AI, just to show how easy it is. That is terrible.
Right. We've got some of them filled in. Let's see if we can get some of the other ones filled in. And I'm going to pick some people if you don't mind. So, Hannah, have you got any of these radians that you could tell me what they are in degrees, please?
Should we actually just fill this in? Should we? Should we, guys? I'm feeling very tired now. It's the holidays, and I'm learning radios for fun. Hey, screw it. I'm gonna do it. It's good practice, anyways. Let me take a screenshot of that. Gotta stop sharing. That's my picture. Where's my screenshot? Oh, here it is. Let's share screen there. Upload my image by advertisements. Right here. Bring doorbells. Ring doorbells are kind of cool. Like, it's a doorbell with a camera. But that's kind of weird. A doorbell with a ring? No, what? No, why? What? No, it's not. Yo, hurry up! No, I'm not using this. This is weird. Oh shit! Like white. Oh yes, Nero. I know this. This is good. Ah yes, something I can trust. Not something like really. Thank you, my savior. Okay, let's start. So you can see that this is the thing that the teacher gave the task of writing the amount of angles. I don't know if we can. I don't know if I can use my calculator, but it's fine. So like this. Uh, okay, first let's do. Okay, this one's obviously degrees. Oh, my handwriting sucks. this one. So it's obviously this is just 1/6. So I think 1 by. Why is it not writing? No, what? One 80 into 1/6, which is just 180 into 6. 90/3, which is just equals. I can't write. It's not letting you write. Bro, why are you writing these things? Oh. Which is equal to. Which is equal to 30. So this is 30 degrees. 1/3. What's 1/3 of this? 60, that's 60 degrees. 2/3. Oh god. 2/3 of that. Wait, this is 1/3 into. Okay, yeah, that's 120. 5 into 6. Isn't this divided by 6? We did that 30. 30 times 5. 150. What? Streaming map. Now, chessboard. Okay, well, that looks like 180. What else? Okay, times 7, so we know it's 30, 30. Okay, that's 210. Divided by 4. Oh! Can we do that? Let us see. Okay, 180. 4, 4, 6, 8, 10. Okay. Oh no, I'm stupid. Ah, okay, so it's times 5. So that's just, okay, so 4, no, 5 into 4, that's 10. Why can I not do multiplication? 200. 225. If that's wrong, I'll kill myself. 60, okay, this is 240. 275. 30, 60. 60 times 5 is 300 degrees. Divided by 4, 45. 45 into 7. 27, 280, 280 plus. Is that 315? Let me check. No, okay, that's 315. 315 divided by 6, that's. Oh, yeah, 360. So that means 300. No, yeah, 30. That was 330. Are you sure? Yeah, I'm sure. Yeah, I'm sure. We did it, guys. Woo, we completed. Math's easy, boy. Except for mental maths. That sucks. Okay, let's continue with the video. No, it's uh. Almost half an hour. I like Disney. It's cool. I wish we could go on the cruise, but I'm not rich. So I'm gonna stay at home and do math because I can afford that. Okay, let's just continue. Technically, that could be 0 and 360. So I'm just telling. Cause you spend like half. Okay, let's see. Or you can just know the 2 pi is just 360. You could also know that. My own thing. I'm just thinking. I don't think table tennis. If you don't know, I like playing chess. I like playing math. I like playing badminton. I like playing table tennis. I like mountain biking. I like butterfly night flipping. I like watching YouTube. I like a bunch of stuff. A lot of dumb stuff. Ah! Okay. 3 pi over 2, that's easy. It's right over here. Right over here. Bro, it's 3 by 2. 3 into 2 is 1.5. 1.5 to 180 is 270. It's right there. Brother. Not that, okay, I'm gonna roast you because I'm also pretty dumb. But that's the wrong answer, so. Here, 45 degrees. Oh, 5 by 4, not 45 degrees. It's over here. Okay, guys, I'm sorry, but I'm getting a call, so we'll watch this later.